In previous sessions, we learned how to calculate the mean, variance, and standard deviation for ungrouped data. In this section, we will learn how to calculate the mean, variance, and standard deviation again, but for the group data. To calculate the mean for group data, first find the midpoint of each class and then multiply the midpoints by the frequencies of the corresponding classes. We will look at example by using a table later. The sum of this product denoted by approximation for the sum of all values. Then divide this summation by the total number of the observation in the data, which is n. And this is the population, and this is for the sample. Population is mu and n capital letter. For the sample, the mean is the S bar and n small letter for the total number of observation. Table 3.8 gave the frequency distribution of the daily commuting times in minutes from home to work for all 25 employees of a company. Calculate the mean of the daily commuting times. So since this is the data for all employees, so we will use the formula for the population. Given here the daily commuting time in minutes, 0 to less than 10, 10 to less than 20, and the rest. And the second column shows the number of employees from 49642 for each class. This is also known as frequency. So this is the frequency. To calculate the mean, we first find the midpoint of each class, which is here. The midpoint m equal to 5 is obtained from the middle value of this class, or the midpoint of this class, 0 to 10, which is 5. 15 is the middle value of this class, 10 to 20, which is 15. And you do the same for the rest class. MF, the last column here, is obtained by multiplying the frequency with the midpoint. 4 multiplied with 5, you get 20, and you do the rest to get the summation of MF. The mean is obtained by dividing this summation by the total frequency. The total frequency is 25. So, to get the mean, summation of MF, the last column, divide by the frequency or number of observation, which is 25, you get 21.4 minutes. Thus, the employees of the company spend an average of 21.4 minutes a day commuting from home to work. Or you divide this column with this column to get the mean for the group data. The second example for the group data, table 3.1 gives the frequency distribution of the number of orders received each day during the past 50 days at the office of a mail order company. So calculate the mean. This is the number of order in class. There are 4 classes here, and this is the number of days, which is the frequency. So put the frequency here and then find the midpoint value for each class. 10 to 12, the midpoint is 11. And then find the MF, 4 multiplied by 11, you get 44. And then get the summation of F, which is N, 50. And the summation of this column, MF, is 832. So just plug in the formula. 832 divided by 50, or the summation of MF divided by N, you get 16.64 orders. Thus, this mail order company received an average of 16.64 orders per day during these 50 days. The variance and standard deviation for group data. So, these following are what we will call the basic formulas used to calculate the population and the sample variances for group data. Again, M is the midpoint and F is the frequency. The standard deviation is obtained by taking the positive square root of the variance, just like the ungrouped data that we did just now. This is for the group data. Again, the shortcut formulas are more efficient to calculate the variance and standard deviation. This is the basic formula, and this is the shortcut formula. Population standard deviation is sigma. To get it, you just square root the variance. This is the variance in population. And this is the variance in sample, S squared. So square root it, you will get the standard deviation of the sample. Example, The following data reproduced from table 3.8 give the frequency distribution of the daily commuting times in minutes from home to work for all 25 employees of a company. Calculate the variance and standard deviation. This is the class of daily commuting time in minutes from 0 to less than 10 and the rest. And this is the number of employees or the frequency. So here is the frequencies. The total frequency, which is equal to n in a population, is 25. This is the midpoint. So 0 to less than 10 is 5. 10 to less than 20 is 15. M multiplied by F here, you will get 20. 4 times 5 get 20. And then get the M square F. So here you have to square it first. 5 multiply 5. And then you multiply with 4. The F here, you will get 100. So do for the rest of the class. Now you will get the summation of MF and also the summation of M square F. Remember, because the dataset includes all 25 employees of the company, so it represents the population. Therefore, we use the formula for the population variance here. So we already calculated the summation of M square F and also the summation of MF square. So just plug in the formula, you will get 135.04. The next step is to calculate the standard deviation, which is sigma. To obtain the standard deviation, take the square root of the variance. Thus, the standard deviation of the daily commuting times for these employees is 11.62 minutes. This is another example. You can refer to your slide. Given here the number of orders, and this is the frequency. So just like before, find the midpoint for each class here. Calculate the MF and M square F. Put it in the formula. We use now the formula for the sample and then get the standard deviation value. Just put the square root, then you will get 2.75. So the standard deviation of the number of orders received at the office of this mail order company during the past 50 days is 2.75. By using the mean and standard deviation, we can find the proportion or percentage of the total observations that fall within a given interval about the mean. This section briefly discusses Chebyshev theorem and the empirical rule, both of which demonstrate this use of the standard deviation from the mean. Chebyshev theorem gives a lower bound for the area under a curve between 2 points that are on opposite sides of the mean and at the same distance from the mean. The definition for Chebyshev theorem is for any number k greater than 1, at least 1 minus 1 divided by k square of the data values lie within k standard deviations of the mean. Or at least 1 minus 1 divided by k square of the values lie in the shaded areas here. This is the mean minus k standard deviation, and this is the mean plus k standard deviation. This figure illustrates the Chebyshev theorem. For example, if k equal to 2 here, this is k equal to 2. Therefore, if you replace k with a 2 here, you'll get 0.75 or 75%. So according to Chebyshev theorem, at least 0.75 or 75% of the values of a data set lie within 2 standard deviations of the mean. This is shown in this figure. If k equal to 3, so here k equal to 3, then you'll get 0.89 or 89% approximately. According to Chebyshev theorem, at least 89% of the values fall within 3 standard deviations of the mean, as shown in this figure. Note that the Chebyshev theorem is applicable to a distribution of any shape. This is a skewed shape. However, Chebyshev theorem can only be used only for k larger than 1. We used example just now, k equal to 2 and k equal to 3. So the value of k must be larger than 1. Why? Because if k equal to 1, the value of 1 minus 1 divided by k square, which is k equal to 1 here, it will give a result of 0. And when k is less than 1, the value is negative. So that's why the k here must be larger than 1. For example, the average systolic blood pressure for 4,000 women who were screened for high blood pressure was found to be 187 mmHg with a standard deviation of 22. Using Chebyshev theorem, find at least what percentage of women in this group have a systolic blood pressure between 143 and 231 mmHg. So the average or the mean, which is we denote as mu here, is 187. And the standard deviation is given to, which is 22. To find the percentage of women whose systolic blood pressures are between 143 and 231 mmHg, the first step is to determine the K. As shown here, the 2.143 and 231 is 44 units away from the mean. The value of K is obtained by dividing the distance between the mean and each point by standard deviation. So K is 44 divided by 22. This is the distance between the mean of each point, and this is the standard deviation. So put K equal to 2 in the formula, you will get 0.75. So according to Chebyshev theorem, at least 75% of the women have systolic blood pressure between 143 and 231 mmHg. This percentage is shown in figure 3.8 or here. This is the mean 187. This is the systolic blood pressure between 143 and 231. So hence, according to this Chebyshev theorem, at least 75% of the women have systolic blood pressure between 143 and 231 mmHg. The empirical rule for the Chebyshev theorem: for a bell-shaped distribution, just like this one, or the normal distribution type, 68% of the observation lies within one standard deviation of the mean, which is here, and 95% of the observation lies within two standard deviations of the mean, and 99.7% of the observation lies within three standard deviations of the mean. The Chebyshev theorem is applicable to any kind of distribution. However, this empirical rule here, 68%, 95%, and 99.7%, applies only to the bell-shaped distribution here. Example, the age distribution of a sample of 5,000 persons is bell-shaped with a mean of 40 years and standard deviation of 12 years. Determine the approximate percentage of people who are 16 to 64 years old. Here we use the empirical rule to find the required percentage because the distribution of ages follows a bell-shaped curve. The bell shape. From the given information for this distribution, X bar or the mean is 40, the standard deviation is 12. Each of the 2 points, 16 and 64, is 24 units away from the mean. Because the area within two standard deviations of the mean is approximately 95% for a bell-shaped curve, approximately 95% of the people in the sample are 16 to 64 years old. So this is the mean, which is 40, and this is the 2 points, 16 and 64, or the mean minus 2 standard deviation, and the mean plus 2 standard deviation, or 24 units away from the mean. 16 minus 40, 64 minus 40.